The normal systolic blood pressure P in milliliters of mercury for an adult male, X years old, can be modeled by the equation P equals X plus 220 divided by 2. According to that model, for every increase of 1 year in age, how many milliliters of mercury will the normal systolic blood pressure for an adult male increase? Key word here for this question is for every increase of 1 year in age. When you hear for every, that's a sign that this question is asking about the slope. And if you look carefully, you see this equation really is a linear function that looks like this, y equals mx plus b. So let's actually make more sense of this. We have x plus 220 divided by 2. You notice that it looks slightly different from the one above here because of this division by 2, but remember, if you have a term on the numerator and the entire term is being divided by some denominator, you can actually separate these and individually divide these. X over 2 plus 220 over 2. And to make this even more readable, we can write this as 1/2 x plus 110. So we see that this slope here is actually 1/2. Why? Because m stands for slope and m happens to be 1/2 for this question. Now, to prove that this is actually true, x means the number of years, right? That's what the question said, x years old. So for every increase of 1 year, so let's say someone is 0 years old. So if x is 0, plug in a 0, it would be 1/2 times 0 is 0, 0 plus 110 is 110. So we increase by 1 year for every 1 year increase in age. So now we make the x value 1. We're increasing from 0 to 1. This should increase by 1/2, so it should be 110.5. Let's plug in a 1 right here. 1/2 times x is 1/2. 1/2 times 110 is 110.5, 110.5. So yes, so we did increase by 1/2 from when we increased by when the age increased by 1 year, the blood pressure increased by 0.5. So we know for a fact that the answer to this is 1/2.